Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of points of inflection. So you've probably already done relative extrema problems. When we're finding the first derivative, we set it equal to 0, we find our critical points, right? These are our possible maxima or minima, and these are both referred to as extrema, right? The extreme, max, min. We use the first derivative test to prove it because the first derivative test tells us about the slope of the tangent lines. And we plug in the test points and do all that. And if it's increasing, decreasing, it's a max. Decreasing, increasing is a min. All right? That should be a brief review on the first derivative test. Well, what do we use the second derivative test for? So when we set the second derivative equal to 0, we're finding what are called possible points of inflection. They're a possible point of inflection because we haven't proven it to be so. Just because it equals 0, the second derivative at that point, doesn't mean it's a point of inflection. We have to put test points on either side of this possible point of inflection into the second derivative. Okay? And once we look at the concavity, the test point will tell us whether it's concave up or down. If it changes concavity on either side, it's a point of inflection. So, looking at this graph here, you see all these green dots. These are all points of inflection. The points of inflection, these green dots, would be listed as an x and the corresponding y. -2 has a function value of 1, so does 1, 3, but here at 4 we have a y value of 2. So you see how they're listed? It's an x and a y. If you're not given a function, how do you find that y value? Well, anytime you want a y value, whether it's for the critical points and the maxes or mins, or for these points of inflection, you always go to the original equation. As I mentioned earlier, you should be able to determine concavity by looking at that graph. So some people that are grading your exam or quiz will allow you to put the point in the form of the x value, comma, f of the x value. What this indicates to the grader is that you know you need the y value. It's an ordered pair, an x and a y value, but you just didn't have time to do it, or a calculator, or whatever the reason. So, I had earlier discussed the regions of concavity. You can depict that from the graph here shown just by looking at the frown, if you will. You see how that's an upside down frown? That's concave down. And that occurs when you get a negative value plugged into your second derivative. Whereas the smile, the concave up, occurs when you get a positive value when you plug in to the second derivative. Again, you will be plugging in a point on either side of these possible points of inflection. And then once it changes concavity from down to up, like right here, that's when you know this green dot is indeed a point of inflection. So do not use union. Some of the people get really annoyed with that and will take off points. Use either semicolon or the word or. So these are the regions of concavity. Go through that, make sure you agree, okay? Make sure you can visualize it. So what if you don't have a picture of the function? How do you approach it? How do you determine concavity? Well, we plug in a test point on either side, just like I just said, of the point of inflection. If I were you, I would draw on a number line. I would have my point of inflection or multiple points of inflection. So let's say, I don't know, for argument's sake, -2 and 4. Okay, these are my POIs. what you'll do is you'll pick a test point on either side of these POIs. Try to pick easy test points like 0 or 1 if you can. And then you'll plug them into the second derivative. Okay, so I'm letting A be my test point. And when I plug in, this means plug in A into your second derivative. If it's greater than 0, it's concave up. The easy way to remember this is, what do positive people do? They always smile. So smiling is the same as that concave up. And then if you plug it in and you get a negative number, it means that it's concave down. What do negative people do? They frown upside down. Okay. Make sure you know the conditions. Once the cavity has been determined to change on either side of the point can now be labeled a point of inflection. All right. So, one last note. Think of a vertical asymptote. If you look on either side of the vertical asymptote, your function can change concavity. So make sure that when you're doing this number line, you don't forget about the vertical asymptote, because that could be concave up on one side and concave down on the other side. Okay, so how do you find your vertical asymptote? If you remember, you're going to set any denominators equal to 0. So whatever is in the denominator, set it equal to 0, and that should also be a critical number. You can't call it a critical point. It's not a point, but it is a number. So you can't make it a max or a min, but it can change increasing, decreasing on either side. You can't make it a possible point of inflection, but as I just showed you, whatever that number is should also show up on your number line. And we'll say that that was at 1. If it's at 1, I would have needed to put a 1 there. And then had one more test point of something between 1 and 4, so 3, doesn't matter, anything in between. And then that would have also got plugged in. So if you would have gotten a number greater than 0, again, that would have been concave up. If it was a number less than 0, it would have been concave down. And you're plugging it into the second derivative. All right? So hopefully that's clarified any doubts that you might have over points of inflection and concavity. Make sure you list the answer in ordered pair form X and Y. Practice, 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 and check out the example videos. Thank you and have a nice day.